In this video, we're going to be talking about the derivative for our trig functions. Now, we talked about these in a previous section, but let's re-look at those now. Here, I have the peak of our sine of x function, and that occurs at pi over 2. And I have a valley at 3 pi over 2 in our sine function. I have another valley at negative pi over 2 and another peak at negative 3 pi over 2. And so our derivative, having the slope at this tangent line here of 0, would have an x value in my derivative of 0. So we would cross the x-axis at each of these locations. From this valley at negative pi over 2 to this peak at positive pi over 2, my slope is up, it's going up, it's increasing. And so from our x-intercepts at this point and that point, we have a positive part of our graph here, things that are above the x-axis. Now let me click the derivative on here and we can take a look at it. And you can see what we're talking about. Here we have our x-intercept at pi over 2, negative pi over 2, negative 3 pi over 2, and so on. Right where our peaks and valleys have occurred in our original function. Notice that when on my sine function at 0, 0, we had a slope of 1. And so we graph the point 0, 1 because the slope of the tangent line at this point is 1. And what function is it that we're looking at graphically? Well, if I click on the cosine function, you don't see it because it landed right on top of the derivative function. And so what we can deduce from this is that the derivative of the sine of x is cosine of x. That's something that we should definitely have written down in our notes. The derivative of sine of x is the cosine of x. Well, what's the derivative of cosine? Well, once again, we have a peak. Our peaks are at 1, pi, negative pi, and I can find them again over here. They're like negative 2 pi and positive 2 pi over here. At this point is where we have a slope of 1, so our derivative must peak at a slope of positive 1 here, and must valley at a slope of negative 1 there. Let me flip it on, and that's what this looks like. Is it the same thing as sine? No, not quite. I mean, sine, it looks a lot alike, right? If I click the cosine off for now, they look a lot alike. In fact, they're symmetrical. So what would I need to do to the sine function so that it landed on the orange derivative of g function? And if I want to flip anything up or down, I put a negative sign out front of it. And so when I put a negative sine of x, it lands right on the derivative of cosine. So our new piece of information, the derivative of cosine, ends up with negative sine of x. And so those are two key pieces that you're going to need to know coming into class tomorrow. Please get those written down. For now, we are done.